Hello, my dear students. Let us solve some problems on this shear strength. Let us take this example. In a direct shear test, the shear stress and normal stress on a dry sample at failure are 0.75 kg per centimeter square and 1 kg per centimeter square respectively. Find the angle of internal friction of the sand. Okay, here you have to calculate phi. Only phi. Why? Because it is not asked to calculate C. In the case of dry sand, it is asked to calculate the friction value for the dry sand. The dry sand C is equal to 0. Okay, so how to calculate? We have the formula tau F is equal to C plus sigma into tan phi. Okay, for this you have to calculate phi. C equal to 0 because this is a sand cohesionless soil. So what it is given, shear stress is given, that is 0.75 kg per centimeter square, and normal stress sigma n is given, that is kg per centimeter, 1 kg per centimeter square. So direct substitution, we have this formula tau F is equal to C plus sigma into tan phi. So C is equal to 0, substitute tau F is equal to sigma NF into tan phi. Okay, so tan phi is equal to tau F divided by sigma NF, or sigma N also you can write, not a problem. So that is equal to tan phi equal to sigma F is equal to 0.75 divided by sigma N is equal to 1. So phi is equal to tan inverse of this 0.75, that is equal to 36.9 or 37 degree. Very simple example. Directly you have to substitute the values, what is normal stress and shear stress, and calculate the angle of internal friction. Let us take one more example. A soil fails under an axial vertical stress of 100 kPa in unconfined compression test. The failure plane makes an angle of 51 degree with the horizontal. Find the shear parameters C and phi. So here we have to calculate what is C and what is phi, shear strength parameter. So phi fails under an axial vertical stress, that is nothing but sigma 1. Okay, this is an unconfined compression test. Okay. So here major minor principal stress at failure sigma 3 equal to 0. Okay, in this case unconfined compression test sigma 3 equal to 0, and major principal stress at failure, that is sigma 1, nothing but vertical stress, that is equal to 100 kPa. So we know alpha is equal to 45 plus 5 by 2. You should know this always. Alpha is equal to means the failure plane inclination with respect to horizontal. So alpha is equal to 45 plus 5 by 2. So 45, 5 plus 2. So it is given the failure plane makes an angle of 51 degree. So that is alpha is equal to 51 and 45 plus 5 by 2. Okay, so you have to calculate phi. So that is nothing but this is 51 minus 45 divided by 2. So we will get phi is equal to 12 degree. Once if you get phi is equal to 12 degree, how you can calculate C? We know this formula, sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2, or sigma 3 tan square alpha plus 2c tan alpha. Alpha is nothing but 45 plus 5 by 2. Now sigma 3 equal to 0. This is the minor principal stress at failure. In the case of unconfined compression test, sigma 3 equal to 0. So this term becomes 0. So the remaining is only 2c tan 45 plus 5 by 2. So based on this you can calculate what is C. So only sigma 1 is equal to 2c tan 45 plus 5 by 2. So if you write in terms of C, C is equal to sigma 1 divided by 2 into tan alpha. So that is sigma 1 is equal to 100 divided by 2 into tan alpha. Alpha is equal to 51 degree. So substitute, we will get 40.5 kilonewton per meter square, or kPa, because this vertical stress is given in kPa. So this also in kPa. Okay, so like this you can calculate what is phi and c for the unconfined compression test. Just remember, in case of unconfined compression test, sigma 3 equal to 0, and always you should know sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Alpha is equal to 45 plus 5 by 2. If you know all these things, you can calculate what is c and phi. Okay, let us take one more example. A sandy soil sample tested in a triaxial compression apparatus failed when the total maximum and minimum principal stresses were 120 kPa and 55 kPa respectively. The pore pressure measured at failure was 15 kPa. Find the effective principal stress ratio at failure and a tangent of the angle of effective shearing resistance of the soil. So here you have to calculate what is the ratio of effective principal stress at failure, and then also you have to calculate the tangent of the angle of the effective shearing resistance, means tan phi. That also has to be calculated. So what's given here? Total maximum principal stress sigma 1, that is equal to 120. Here it is given maximum and minimum principal stresses are 120 and 55 kPa. So maximum principal stress sigma 1 is equal to 120 and sigma 3 is equal to 55, and pore pressure, that is U is equal to 15 kPa. Okay, so now it is asked to calculate effective principal stress ratio at failure. Effective principal stress means sigma dash. Okay, that is nothing but sigma minus U. So now the ratio is, principal stress ratio at failure is sigma 1 dash to sigma 3 dash. Sigma 1 dash is what? Sigma 1 minus U, and sigma 3 dash is sigma 3 minus U. Okay, so sigma 1 is given 120, U is 15, 120 minus 15, and here sigma 3 is equal to 55 minus 15. So we will get 2.6. Always you remember, effective principal stress, that is nothing but the from the total stress you have to deduct the pore water pressure. That is this sigma dash, sigma 1 dash or sigma 3 dash or sigma dash, that is nothing but sigma minus U or sigma 1 minus U or sigma 3 minus U. Deduct the pore water pressure from the normal stress. Okay. Now first part is done. The second one is they have asked to calculate what is the tangent of the effective shear resistance. In this is given, this is a sandy soil, so C is equal to 0. Okay, here everything is in terms of effective shearing resistance, so it is dash. You have to use dash, effective shearing resistance. So C dash is equal to 0. We know sigma 1 dash, that is nothing but sigma 3 dash tan square alpha plus 2c tan alpha, or alpha is equal to 45 plus 5 dash by 2. Okay, now we have C is equal to 0 here, so this term will not be there. So only sigma 1 dash is equal to sigma 3 dash into tan square 45 plus 5 dash by 2. We have tan square 45 plus 5 dash by 2, right, in terms of like this. So for get tan square 45 plus 5 dash by 2 this side, that is equal to sigma 1 dash divided by sigma 3 dash. We know sigma 1 dash by sigma 3 dash, that is equal to 2.6. So substitute here 2.6. So tan square 45 plus 5 dash by 2 is equal to 2.6. So only one unknown 5 dash. So 5 dash is equal to 26.4 degree. So it is asked to calculate tangent of the angle of the effective shearing resistance. So you have to calculate what is tan phi dash. So tan phi dash is equal to tan of 26, tan inverse of 26.4. So you will get tan phi is equal to 0.5. Okay, this is nothing but phi dash is 26.5. So what is tan phi? So write in terms of tan. Okay, I hope all of you understood. Let us take one more example. What is the shear strength in terms of effective stress on a plane within a saturated soil mass at a point where The total normal stress is 285 kPa and the pore water pressure is 110 kPa. The effective shear strength parameter C dash is 15 kPa and phi dash is 35. Okay, here the total normal stress is given, that is sigma n 285. Pore water pressure is given 110. Effective shear strength parameter C dash and phi dash is given. So, how to calculate the shear strength in terms of effective stress? What is that? Tau F, otherwise tau F is equal to C plus sigma n tan phi. But this is in terms of effective stress. So, tau F is equal to sigma n dash tan phi dash plus C dash. Okay, what is sigma n dash? Sigma dash, I told already, when the dash effective stress is there, you have to deduct the pore water pressure. So now sigma n dash is nothing but sigma n minus u into tan phi dash plus C dash. So sigma n is given to 85, u is 110, deduct that, into tan phi dash is 35 plus 15. So we'll get 137.5 kPa. Very simple. Okay, main thing you should know, when it is asked to find in terms of effective stress, that becomes sigma dash. So that time you have to deduct the pore water pressure. Let us take one more example. A drained triaxial compression test on a saturated clay yielded the effective shear strength parameters as C dash is equal to 16.5 kPa and phi dash is equal to 26 degree. Consolidated undrained triaxial test on an identical sample of this clay at a cell pressure of 100 kPa developed a pore water pressure of 55 kPa. What is the deviator stress at the failure? Now it is asked to calculate what is deviator stress. Okay, so what is the, it is a drained triaxial compression test on saturated clay. Okay, C dash is given, that is 16.5, phi dash is given 26 degree, and consolidated undrained test on identical sample of this clay at a cell pressure. Cell pressure is always equal to sigma 3, so that is equal to 100 kPa, and pore water pressure U, that is 55 kPa. So now sigma 3 dash, we know that is nothing but 100 minus 55, that is equal to 45, because from the normal stress you have to deduct the pore water pressure. We have sigma 1 dash is equal to sigma 3 dash tan square alpha plus 2c tan alpha. So here this is sigma 3 dash, that is 45 into tan square alpha, 45 plus 5 by 2, phi is 26 degrees, so 5 by 2 is 13, plus 2 into C dash, that is 16.5 into tan of 45 plus 5 by 2, phi dash by 2, that is 13. So simplify this, we will get sigma 1 dash is equal to 168.05 kPa. Now you have to calculate what is deviator stress at failure. Deviator stress, that is equal to sigma d, that is equal to sigma 1 minus sigma 3, but it is in terms of effective stress because here pore water pressure is given. So that is sigma d is equal to sigma 1 dash minus sigma 3 dash. Sigma 1 dash is equal to 168.05 and sigma 3 dash is equal to 45. So simplify this, we will get 123.05 kPa. So like this we can calculate what is deviator stress at failure. Okay, so very simple. Mainly you should know all the terms. What is C dash, what is phi dash, what is sigma 3 and what is U. So sigma 3, that is cell pressure in case of drain triaxial compression test, and U is pore water pressure. Sigma 3 dash is always that is dash means you have to deduct the pore water pressure. So then the sigma 1 or sigma 1 dash, that is always this formula you have to remember. Okay, sigma 1 or sigma 1 dash is equal to sigma 3 dash tan square alpha plus 2c tan alpha. Alpha is 45 plus 5 by 2. Then you have to calculate deviator stress. Deviator stress is nothing but sigma d. If it is in terms of normal stress, then it is is just sigma d is equal to sigma 1 minus sigma 3. But if it is in case of effective stress, sigma 1 dash, sigma d is equal to sigma 1 dash minus sigma 3 dash. I hope all of you understood. If you have any difficulty, we can discuss later. Thank you.